Welcome to Veera's classroom. In the series of signal flow graph problems, in this video we are going to see a signal flow graph problem which is completely different from the previous problems. In the previous problems we have been given a signal flow graph diagram and we have been asked to find the overall gain by using Mason's gain formula. This is what we have been asked to do in all those problems, but here we are supposed to construct the signal flow graph diagram first. First step is to construct a signal flow graph, then we will follow the same procedure which we have followed in Mason gain formula to get the overall gain. So they have given a set of algebraic equations. By using these equations we are supposed to draw the diagram. So what are the algebraic equations here is x2 is equal to g1 to x1 plus g3 to x3 plus g4 to x4 plus g5 to x5. This is equation number 1. The second equation x3 equal to g23 x2. Third equation is x4 equal to g34 x3 plus g44 x4. Fourth equation is x5 is equal to g35 x3 plus g45 x4. Here they have also denoted as x1 is the input variable and x5 is the output variable. This is the input given. Based on this input we are supposed to draw the signal flow graph. After drawing the signal flow graph we will go with the basic solving of signal flow graph by using Mason gain formula. So here the variables x1, x2, x3, x4, x5 are the nodes located from left to right. So I am just marking it and I am showing it to you. That's x1, x2, x3, x4 and x5 are the nodes. So we will take each and every equation and we will draw the signal flow graph diagram. So in this, the first equation, we are taking the first equation and I have drawn the diagram. I will tell you step by step. Here they have given it as, here we will see the first equation. It is x2 equal to g1 to x1 plus g3 to x3 plus g4 to x4 plus g5 to x5. We will take each and every term. So we will take the first term, that is g1 to x1. So what does it mean is, from x1 we are getting a signal g12 to x2. So that has been mentioned here. This is first for the first term. For the second term, g3 to x3, it is a signal g32 is been moving from x3. So that has been mentioned here. This is second. The third one, it is g4 to x4. A signal g42 is moving from x4 to x2. That has been shown here. The last one, g5 to x5. A signal g52 is moving from x5 to x2. So these are the four signals that moves from x1, x3, x4 and x5 to the x2. Based on that, the diagram has been drawn. This is for first equation. What I am doing here is I am drawing the signal flow graph for each and every equation, and at last I will combine all those things to find the common signal flow graph for all the equations. So we will move on to the second equation. Second equation is simple. It is x3 equal to g23 x2. So what is the term here? It is this is going to be x2 and this is going to be x3. So this is x2, this is x3. So what they have written, x3 is equal to g23 into x2. So there is a signal that is going to flow from x2 to x3. So the signal is g23. This is the signal that is going to be flowing from x2 to x3. So the next one, equation number 3. The equation number 3, if you are going to see the equation number 3, that is x4 is equal to g34 x3 plus g44 x4. So we will take first one. The first one is a signal g34 that is flowing from x3 to x4. So that has been shown here. When you are going to see this second term, it is g44 x4. We have already seen the node is x4 and it has been mentioned as x4. So it is moving from x4 to x4. So it is simple like moving from x4 to x4. The signal is going to be g44. So equation number 3 is been completed. We will move on to the equation number 4. The fourth equation is x5 is equal to g35 x3 plus g45 x4. So when you are going to see the first term is G35 X3. So a signal G35 is moving from X3 to X5. So it is moving from X3 to X5 G35. The second one is G45 into X4. A signal G45 is moving from X4 to X5. So we have drawn signal flow diagram for each and every equation, but our objective is to combine all those things to find a overall signal flow graph. So I have combined all the diagrams to form this signal flow graph. This is the signal flow graph for the set of algebraic equations which is given in the question. Now only the actual process of getting the overall gain is going to start. So we are going to solve this problem, signal flow graph, by using the steps such as finding the forward path, finding the individual loop gain, then two non-touching loops. All those steps will be solved. So till this we have not getting a signal flow diagram. Based on the equations we are constructing the signal flow diagram. So now we have drawn the signal flow diagram. Now we will move to the step number 1, that is forward path gain. What is meant by forward path gain? We have to flow from x1 to x2. So our flow should be from x1. It should start from x1 and it should end at x5. This is the forward path. So basically we will have a forward path every now and then. When you are going to check a signal flow graph, we will always have a straight line forward path always, that's flow from the starting point to the ending point. This is forward path 1. Now we will check whether we have another forward path. When you compare this G32, G32, G42, G52, all are flowing in the reverse direction. So this is not going to constitute in the forward path. It's going to be in the reverse. That's going to be either a feedback or individual loop. So we will check this one. This G35. This G35 is flowing in the forward direction. So we will see this. So this is going to give a forward path. Yes, it starts from x1, moves to x2, moves to x3, then jumps to x5. So we have two forward path. First one starts from x1, moves to x2, x3, x4 and x5. This is first one. The second one starts from x1, moves to x2, moves to x3 and jumps to x5. So we have two forward paths. So our first forward path gain has two forward path P1 and P2. The gains of P1 is G12 into G23 into G34 into G45. This is first one. The second one P2 equal to G12 into G23 into G35. So we have two forward path gains. We will move to the step 2. Step 2, what is step 2? We are going to find individual loop gain. What is meant by a loop gain? We want to start from one node and it should return to the same node. So those flow of signals will be called as loop. So we will check each and everything because we have three different equations, the signals that flows in the reverse direction. So we will start with G32. See here it starts with x2, goes to x3 and comes back to x2 itself. So this is one loop, individual loop. What about the second one? The second one starts from x2, moves to x3, moves to x4 and comes back to x2 again. This is individual loop 2. And the third one, it starts from x2, goes to x3, goes to x4, goes to x5 and comes back to x2. This is individual loop number 3. And we have one more small individual loop that flows in the x4 itself. This is individual loop number 4. We have 4 individual loops. Apart from that, we have one more individual loop. It starts from x2, goes to x3 and jumps to x5 and comes back to x2. This is one such individual loop that moves to G5, G35 and comes back. So we have 5 individual loops. So those 5 individual loops will be listed here: P11, P21, P31, P41 and P51. So all those individual loops has been mentioned. So the gain of P11 is G23 into G32. The gain of P21 Second loop is G23 into G34 into G42, P31 equal to G44, P41 equal to G23 into G34 into G45 into G52. The last loop is, the gain of last loop is P51 equal to G32 into G35 into G52. So we have found the individual loop gains. Step 3, to find the gain product of two non-touching loops. We'll check the diagram again and find whether we have any two non-touching loops. So we'll always go with the smaller one. We'll consider the smaller one and check whether this individual loop is not touching with any of the other individual loops. So here we have one loop. This loop doesn't have any common point with this loop, so this is one pair. Other thing, the next pair, this is the first one, and the other loop which doesn't have any common point with this individual loop is this loop, because this starts from x2, goes to x3, jumps to x5, it doesn't have any common x4, so these two will form another pair. Apart from that, any other pair? No, all the things have one common point, because G32 and G42 has two common points, G32 and G52 also two common points, G32 and G35 has two common points. So we have two pairs of non-touching loops. So we will name it as P12, that is multiplication of P11 into P31. So the gain product of these two is G23 into G32 into G44, and the second pair P22 equal to P51 into P31, that is G23 into G35 into G52 into G44. After that, we are supposed to check whether we have any gain product of 3 non-touching loops or 4 non-touching loops, etc. But there are no possible combination of 3 or 4 non-touching loops, so we will mention that as 0. What is the last step? That is step number 5, to find del and del k. What is the formula for del? Del equal to 1 minus sum of individual loop gain plus sum of gain product of 2 non-touching loops minus sum of gain product of 3 non-touching loops, etc. The step number 5, to find del and del k. Here the formula for del is del equal to 1 minus sum of individual loop gain plus sum of gain product of 2 non-touching loops minus sum of gain product of 3 non-touching loops, etc. We do not have any sum of gain product of 3 non-touching loops, so the equation is going to end with sum of gain product of 2 non-touching loops. We have all those data, we will just substitute it here and get the value for del. So the value for del is del equal to 1 minus G23 into G32 plus G2334 G42 plus G44 plus G23 G34 G45 G52 plus G23 into G35 into G52 plus G23 G32 G44 plus G23 G35 G52 G44. So we will multiply the negative sign inside, so the value of del becomes del is equal to 1 minus G23 into G32 minus G23 into G34 into G42 minus G44 minus G23 into G34 into G45 into G52 minus G23 into G35 into G52 plus G23 into G32 into G44 plus G23 into G35 into G52 into G44. This is the value of del. The next step is to find the value of del k. Del k is based on the number of forward paths. K denotes the number of forward paths. We have 2 forward paths, so value of k is 2. So we are supposed to find the value of del 1 and del k. So what is the formula for del 1? It is to find 1 minus non-touching individual loops, that is that individual loops that is not being the part of that forward path. So when you are going to consider the first forward path and we are going to check with the individual loop gains, the first forward path is going to be a straight line. So each and every individual loop has a common point with this forward path. So we do not have any non-touching individual loops. So this del 1, the value of del 1 is always 1 minus 0, that is value is 1. When you are going to check with the forward path 2, the forward path 2 goes to x3, jumps to x5. So this is the forward path. So when you are going to compare these 5 individual loops, this individual loop alone doesn't have any common point with this forward path. So this is going to be the part of del 2. So del 2 equal to 1 minus G44. So del 1 value is 1 minus 0 equal to 1, del 2 equal to 1 minus G44, so the value is 1 minus G4. Now the last step, step number 6, overall gain. Formula is T equal to x5 by x1. x5 is the output, x1 is the input, which is equal to 1 by del summation k equal to 1 to n pk del k. We will substitute the summation, that is expand the summation. So T is equal to p1 del 1 plus p2 del 2 by del. We will substitute the values and write the final answer. So the value is T is equal to G12 into G23 into G34 into G45, that is first forward path, plus G12 into G23 into G32 into 1 minus G44. The 1 minus G44 represents the value of del 2, whole divided by 1 minus G23 into G32 minus G23 into G34 into G42 minus G44 minus G23 into G44 into G45 into G52 minus G23 into G35 into G52 plus G23 into G32 into G44 plus G23 into G35 into G52 into G44. This is the final transfer function for the signal flow graph by using Mason's gain formula. With this problem gets over. If you like this video, please share it with your friends and give a positive comments in the comment section, and subscribe the channel, click the bell icon for constant updates. Thank you.